This podcast is going to cover how to write chemical equations from word equations. Some things you need to know before we start is you are going to need to be able to convert words or names of compounds to symbols and formulas. So therefore, you're going to have to know what the charges are of an element to determine what the subscript should be, because we're going to be making new formulas. And then the final step will be to balance the equation. Okay, so the first thing I'm going to do is underline or highlight anything that looks like an element or compound. So here I have calcium. Reacts with is a plus sign. And I have sulfur. To form is an arrow. Calcium sulfide, which is a compound. So let's go ahead and convert these words to symbols, starting with calcium. And calcium is all by itself, so I don't need to put any subscript or worry about that. And it's a metal, it's not a diatomic element, so I don't put a 2 in the subscript. Reacts with sulfur, the symbol is S. Again, we're not dealing with a diatomic element, so it doesn't need subscript, it's standing by itself. To form calcium sulfide. So calcium is a Ca and sulfide is sulfur, which is S. Now, before I move on and balance this equation, I need to make sure that I look at what the charges of calcium and sulfur are to determine the proper subscript. So calcium has a +2 charge and sulfur has a -2 charge. Because my charges are opposite but equal, I'm not going to need to write any subscript because they're in a 1-to-1 ratio. So I'm going to go ahead and erase the charge because a neutral compound never has a charge. And now I'm going to worry about balancing my equation. So I'm going to draw that line between my reactant side and my product side, and I'm going to tally up. I have 1 calcium on this side, 1 calcium on this side. Those are balanced. I do not need a coefficient. Here we have 1 sulfur and 1 sulfur. Therefore, I don't need any coefficients, and this equation is balanced just the way it is. Okay, using the same approach, I'm going to underline. This is a compound, iron 2 nitrate. Reacts with means plus. Sodium chloride is my second compound. To form is an arrow. I have sodium nitrate as a compound and means plus. And iron 2 chloride is my second compound that's a product. So now I'm going to start by converting to symbols. The symbol for iron is Fe, and I have to look at the name at those Roman numerals to determine what the charge is. Metals are always positive. So this iron has a +2 charge. Nitrate, that ATE ending, tells us it's a polyatomic ion. And the charge for that is a -1. So in order to make this a neutral compound, I'm going to need to drop and swap. So this 2 comes down outside of nitrate, and I need to put parentheses or else it looks like I have 32 oxygens, and that's just silly. And I'm not actually going to write the 1 on iron because 1 is assumed. Reacts with is a plus. Sodium chloride, sodium is Na with a +1 charge. Chlorine is a -1 charge. And now looking, they're opposite but equal charges, so I don't write any subscript, and we never write 1. So this is neutral at a 1-to-1 ratio. To form, sodium nitrate, again, Na, +1 charge. Nitrate is NO3 with a -1 charge. Again, we have equal but opposite charges, so all I need to do is erase those charges for my neutral compound. And is a plus sign. Iron 2 chloride. So this is iron, again, with a +2 charge, and chlorine with a -1 charge. These are not opposite but equal, so I'm going to drop and swap my charges. The 2 that is a charge for iron becomes a 2 in the subscript for chlorine. And again, I'm not going to drop that 1 because 1 is implied if you have no other number there. So now that I've done this and I've created neutral compounds, I can go ahead and draw a line and start to tally up and balance. When you balance, you can only change the number in front or the coefficient. So here I have 1 iron and 1 iron, that's balanced. Going on to our next element and looking at our polyatomic ion, I can count this as a single unit as long as NO3 is intact on the other side, and it is. So here I have 2 nitrates and here I only have one nitrate. So I'm going to focus on the side that's smaller, and we're going to use multiplication. So 1 times 2 will give us 2 nitrate. So I'm going to put a 2 in the coefficient spot. At this point, I cannot change my subscript because that was determined by the charge of the compound, of the element within the compound. Okay, moving on to sodium. I have 1 sodium on my reactant side, and I have 2 sodiums now on my product side. So I'm going to take this 1 sodium, and I'm going to multiply it by 2 in the coefficient spot, so that now I have 2 sodiums. When you have a compound and a coefficient, that 2 is going to apply to everything that comes after it in the compound. So think of it as the distributive property. I have 2 sodiums. I also have 2 chlorines. Looking on the other side, I have 2 for the subscript and no number in the coefficient, which means 1, so I have 2 chlorines here. So let's erase all this extra stuff, and you can see that we've balanced it by adding coefficients. Okay, in our last example, we have propane, and we are given the formula for propane. Burns in oxygen is a fancy way to say plus oxygen. To form is an arrow, carbon dioxide, and water. So let's go ahead and start by writing out our equation the way it is. C3H8 is propane. Burns in oxygen is plus O2. And that will form carbon dioxide, covalent compound, and water, which is H2O. In this situation, because we have a covalent compound, 2 covalent compounds, we don't need to look at the charges. We just look at the prefixes to determine what the subscript should be. So carbon dioxide is carbon with 2 oxygens, and so we write it that way, so we don't have to worry about making neutral compounds. Now that we have this written, we can worry about balancing. The only thing I can change after I have my compounds written, and I have neutral compounds if that applies, is the coefficient. So I'm going to draw my lines separating my reactants from my products, and let's start with carbon. Here we have 3 carbons, and on this side we only have 1. So I'm going to think of a number that I can multiply by 1 to get 3, which is 3. Now they're balanced. Moving on to hydrogen, I have 8 hydrogens on the reactant side and only 2 over here on the product side. So I need to think of what times 2 will give me 8, and that number is 4. So now I have 8 hydrogens on both sides. One approach I like to do with a combustion problem, and that's where you have carbon dioxide and water as your products, is to approach the oxygens backwards. I save them for the end, and I like to approach them backwards because they're a little tricky. So right here I have an oxygen, and here I have an oxygen. So I'm going to use my distributive property. 3 times 2 tells me I have 6 oxygens here. We are separated by a plus sign, and over here I also have oxygens. 4 times, and 1 is assumed, right here is 4. So on this side I have a total of 10 oxygens. I need to go back to my reactant side and make sure that I have 10 oxygens on this side as well. So I need to think of a number that I can multiply by 2 to get 10. So I'm going to put 5 in my coefficient spot. So now I have a balanced equation.